Hello everyone. Now I will be explaining an example. So the question is determine the current in the network and the voltage across the resistor in this network. So this network consists of a voltage source and silicon and a germanium diode and a 5.6 kilo ohm resistor. So we need to find the current through this network and the voltage across this resistor. Okay. Now let us see about the silicon germanium ideal diodes before solving. Now what are these and how they are represented? Now, this is how a silicon diode is represented with Si, and this is how a germanium diode is represented, and this is an ideal diode. Now, as you all know that this is the anode, which is the positive terminal of the diode, and this is the cathode, which is the negative terminal of the diode. Now, whenever the silicon diode is in on state, it can be replaced by a 0.7 volt drop across it, and whenever the let me take the pointer, and whenever the germanium is in on state, it can be replaced by a 0.3 volt drop across it, and whenever this is in off state, by an open circuit, and this is also by an open circuit. And for ideal diodes, whenever it is in on, it should be replaced by a 0 volt drop across it, that means short circuit, whenever it is in off state, by an open circuit. Now let's talk about the open circuit more. An open circuit can have any voltage across its terminals, but the current is always zero. That means across the terminals the voltage can be anything for an open circuit, but the current between those terminals is zero. And for a short circuit has a 0 volt drop across its terminal. That means both terminals are connected for a short circuit. Okay. Notation of voltage sources. Now this notation is common for the voltage sources. Whenever you find a 10 volt in the circuit, it can be replaced by this, by a voltage source of 10 volt with positive terminal being 10 volt and the negative terminal is connected to ground, that means 0 volt. And whenever you find minus 5 volt, you can replace by a voltage source with negative terminal being minus 5 volt and the positive terminal connected to the ground, which is 0 volt. Okay, by keeping these in mind, we can start to solve the question. First of all, let's find the current to the network. For this we need to apply the KVL. Now this is the network. Look, I have replaced a silicon and germanium diodes by their respective drops. Now, how did I replace? First, we need to see in which direction current will be established. Now, for this 12 volt source, the current will be established in this direction. That means it matches with the arrow of the diodes, both the diodes. That's why I replaced by silicon by 0.0 volt drop and 0.3 for the germanium. Now we can apply the KVL, which is a 12 volt minus 0.7 volt minus 0.3. 12 volt minus 0.7 minus 0.3 minus the voltage drop across the resistor, which is the current through the resistor, and the resistance of the resistor is equal to 0. IR, which is the current through the resistor, which is same as the current through the diodes as they are in series, which is equal to 12 volt minus 0.7 minus 0.3 divided by 5.6 kilo ohm. Now they are approximately equal to 1.96 milliampere. Okay, we have finished calculating the current to the network. Let's calculate the voltage across the resistor. We need to find the voltage across this resistor. That means the voltage, the potential difference between these 2 points we need to calculate. So which is nothing but the current through the resistor times the resistance of the resistor according to the Ohm's law, which is 1.96 milliampere into 5.6 kilo ohm, which is equal to the 11 volt. So 12 volt drop is distributed by 1 volt drop across these both diodes and 11 volt drop across this resistor. Now that's it. We have calculated both the current through the network and voltage across the resistor. This is the end of the lecture. Hope you like the example and stay tuned for the more examples. As I said in my previous video, I will be uploading a video every 2 days, but I have changed my mind. I will be uploading a video every day. So subscribe for the more examples. That's it. Thank you.